Hello students, my name is Ajitesh Moy Ghosh. I am Assistant Professor of Computer Science and Engineering Department of Adamas University. Today I am going to talk about the programming and data structure using C++. This is Module 2 and Lecture 1. Today's topic is C++ as programming language, then array as a pointer, structure and stack. We know that C language and the C++ language compiled and becomes the machine code. Now in case of C++, the compiled file becomes an object file, as because C++ is object oriented programming language. Now compilation of both C and C++ is done in little bit different manner. That compilation of C files is top to bottom and compilation of C++ file is bottom to up. So this is little bit different, and there are some more difference that in case of dynamic memory allocation in C, we use calloc, malloc, realloc, and then to free the memory we use free. But in case of C++, dynamic memory allocation is done using the new operator. And in C, we have structure, and in C++ we have class concept. So as because the class concept is present in C++, we have the base class concept, we have the child class concept, we have the inheritance concept. That means the features which are present in base class can be used in derived class, that is inheritance. And inheritance can be classified into few more categories, like single inheritance, when one child class is inherited from a single base class. This multiple inheritance, then more than one child class is inherited from a single base class. Multi-level, one inherited class or one child class also can be a base class of another class. So it is multi-level. Then hierarchical, also we can see that a child class can be a base class of another class or more than one class in a hierarchical manner. So all these things, and also polymorphism, abstract class, then virtual function, pure virtual function, all these things are present in C++. So these are all features of object oriented programming language. Now after compilation, this object file, what we have just mentioned, that this object file compiles with the help of multiple source files and then linked into an executable file. Here we are talking about multiple source files, means suppose some inbuilt function we are using. Let us consider cout, that is console output, and cin, console input. When we are using cout and cin, the functionality of this is mentioned in IOStream class. So IOStream, input output stream, contains the functionality of cout and cin both, and these source files also get compiled and linked into a executable file. And we can see that in C++, the hash which is used as a preprocessor, it replaces the entire header file, so that compiler will be able to understand that what actually the particular functionality of cout, cin or other which we use within the body of the program. So this functionality will help compiler to understand, and also it is compiled and compiled easily, and it linked with the executable file. As we know that there may be certain functionality which compiler needs to understand, so there will be a translation unit during the preprocessor. That means preprocessor will do what? Will make a note of everything which actually mentioned within the header which we include, and will pass it to compiler, and compiler then will be able to understand what actually the meanings of certain functionality which are mentioned within the body of the program. So all in all, the compiler is able to get all the information from the preprocessor translation unit, which actually help to translate all the information which compiler needs to process it or compile. And this object file, what we are talking about, has an extension of .o. So this actually a very important file, object file, and compiler starts compilation and produces it. So I hope students are able to understand the process of compilation. Now we talk about array. Array is a very important data structure both in C and C++. We can have one-dimensional array, we can have two-dimensional array, we can have multi-dimensional array. So one dimensional array will have only single row and more than one column or one column, whatever may be. Two-dimensional array will have more than one row and more than one column, and this particular array name is point always to the first position of the array. That means, suppose in case of the first picture, if the array name is ARR, this particular name will point to the first position, that is 0th position. Similarly, in case of the second picture, if the array name is ARR1, then it will point to 0 column and 0th row. So that means always array name will point to the first position of the array. So this is very important concept, because this can give us certain idea how to get the values from the different position of the array. Now, to form an array, we can use for loop, or we can declare and initialize the array with elements. When we try to implement the array, we can also use the pointer, which also a very important concept. This pointer, when it is assigned with the first position, that means pointer we know can store the address of the position. So if we give ARR 0 for the first picture, PTR is a pointer, integer type pointer. So we can declare int star PTR, comma ARR, and we can mention the dimension within third bracket open and third bracket close, and we can mention the dimension. Let us consider the array which we are mentioning can store 5 elements. So we can do what? PTR is equal to ampersand of ARR, we can mention like that, or else we can do PTR is equal to ampersand ARR, then within third bracket open third bracket close we can mention 0. So it is a very important concept that PTR brings, which actually stores the address position 0. Now in case of the second picture, the same thing can be done. The pointer can point to the 0th row, 0th column, and again we can do it with the help of PTR is equal to ampersand ARR1 within third bracket open third bracket close we can mention 0, or and third bracket open third bracket close again 0, because 0th column 0th row for the second picture, it is 2-dimensional, so that's why. Or else what we can do PTR is equal to ampersand ARR1. So it will then store the address of the 0th row, 0th column. So we now can understand that how an array can be implemented. And another important information I want to pass on to you, dear students, that is array can store similar type of elements having same data type, or array can store arbitrary elements having same data type. That means if in an integer array we want to store a float value or a character value, that is not possible. So array can only store the values having same data type. And we can also have n dimensional array. So in that case we can have the multiple copies of two-dimensional array, so we can increase it as per our requirement, the dimension. Here you can see what we have just mentioned. We have taken one array and we have declared it. We have not implemented using the for loop. We have declared it directly. So we can see 5 elements and an integer type pointer we have considered is equal to ARR. So we know that ARR points to the first element of the array. So PTR will store the address of the 0th position of ARR. Now to print %p will give the value, address value. It will not give the value which we want, that 1. If we give the print f %d then comma star ptr, then it will give the value stored in the address. Correct? Now in case of 2D array, you can see that 0th row, 0th column is represented A00, and then 0th row first column is A01, 0th row and second column is A02 and A03. All these are mentioned, and row 1 0 is it is also for the second row. Suppose ARR is a 2D array, we can access any element of ARR ij, and we can do it by using the for loop, nested for loop rather, that is a for loop within a for loop. Here I represents the row and j represents the number of elements within the column in a single row. Now array as a pointer is a very important concept which we must know. Here ARR plus I actually mentioning about the row, which row we would like to focus on, and plus j, if we do plus j, it will then go to that particular column of that row. If we do not have 2D, two-dimensional array, if it is single dimensional array means 1D, then we do not need to put the j. So we can then straight away write ARR plus I, that will give us the position error wants to point. Now if we give the star, this star will then bring out the value from the ith position, and if we give plus j and then for the 2D array and then put the outermost star, then within the bracket star arr plus I, this star arr plus I is fetching the row, which row it is actually pointing, then plus j particular column, then at the outermost at the beginning we put a star, then it will bring out the particular value. Let us consider one example. Suppose in the I we put 2 and in the position of j we put 3, then you can see from the picture A23, the rightmost bottom part A23, the value of that position will be printed, correct? Structure I have categorically mentioned here as because it is also considered within the data structure, but it is only present in C. So we can declare a structure called struct using struct and then a name of the structure, struct point. Then within the structure we can mention structure member elements. We can also mention structure member function as per our requirement, and at the end of the declaration we have mentioned P1, and that P1 is a declared variable with point. Point is the name of the structure. Now structure declaration can be done in the second example what we have mentioned. In that manner it can also be done. The struct point, struct which actually indicate that it is a structure, then point, then within the structure we have mentioned int x comma y, that is structure member elements. Then within main function we are mentioning struct point P1. Struct point P1 means P1 is a variable declared like a normal variable. Now with the help of P1 we can access P1.x or P1.y. So we can access the structure member elements like that. Stack, which are very important concept in data structure. Actually, stack store the temporary variables present in the program, and it follows last in first out method. Now what is that? In the picture you can see there are few elements inserted within the stack, and are few elements we are trying to insert, and some element are going out of the stack. Now let us consider a series 40, 30, 20, then 10. This 40 is the first element which we want to insert within the stack. So we will push 40. So it will enter into the stack at the first position where 20 is now present. So first element, if we try to enter, 40 will be the element which will enter first. Then again we try to push the element, second element, which is 30. So it will push down the 40 below. So it will go to the second position where 30 is now present. The 40 will be there and 30 will be at the position first where 20 is now present. Then again we try to push another element, which is third element, that is 20. Then 40 will be pushed down further and it will be at the bottom position. Then at the middle position 30 will be there and 20 will be at the first position. So in that manner the elements are pushed into the stack. It is kind of a thing that we are putting some clothes or some books within a bag. We can consider that suppose we are putting a first book, then again we are keeping other books on the top of the book which we have already placed within the bag. So it is something like that. So we will take out the book which we have kept at the last. So that is last in, first out. So we can understand from this particular example picture that the stack operation is performed from a single side. So the element, if we want to take out of the stack, can be popped out only from the same side from where the elements were pushed into the stack. Here peak is actually pointing to the elements which we have inserted at the last. That means it is acting as a pointer and points to that position where the last element inserted. So we can see from here that by keeping track of that pointer, we can very well understand and track that whether the stack is completely full or there are some opportunities there that we can input another elements. So this is the stack operation. We will see certain other examples how we can do the stack operation, and it is completely based on the LIFO, last in first out type. So when we enter any new element into stack, we call it push, and when we try to delete one element from the stack, we call it pop. So push and pop are the two functionality of stack where we input or insert element within the stack, and pop, we delete element from the stack, and by following last in first out method. So student, we have learnt array as a pointer and stack operation, and these are very important concepts because these concepts are the foundation of the data structure, and you must go through this. And if you have any query, please do not hesitate to connect me to the email ID given below. Thank you.